Hello, good evening. My name is Salako Oluwadolapo. You are welcome to the fourth day of the seminar, How Robots Might Change the Future of Jobs. Like we have always reinforced, this is a non-technical seminar, which means irrespective of your skill level, you can always access and understand the contents of the seminar. So far, we have discussed the concept of robotics and automation. We looked into that on the very first day of the seminar. We have looked into areas of automobile manufacturing employing industrial robots. We did justice to that on the first day of the seminar also. We have looked into the healthcare systems and analyzed the use of smart beds, the use of robot assisted surgeries, robots in surgical operations generally. We have looked into the use of smart delivery systems, and we have also looked into the retail industry that was yesterday, and we analyzed smart stores. We looked into customer service robots, we looked into warehouse management robots, and we looked into delivery robots. So these are the things we have discussed so far. You can do well to refer back to the previous videos in order for you to gain real cognition and understanding of the contents of our discussion so far. Today we'll be looking at the transportation industry generally. Now, the transportation sector is also witnessing a very high influx of some sort of automation. We've looked into how automation is disrupting the manufacturing sector, especially the automobile sector. We've looked into healthcare, we've looked into retail, but the transportation industry is also one of those industries that are not left out by these changes. These automations are really diverse, as some are designed to reduce accident rates, while others are designed to enhance productive cargo delivery. Yes, the systems of automation in the transportation sector is really diverse. Others are specially catered for there to be safer, means of transportation, means of commute, like the instrument landing system, which actually helps airplanes to know where to land, know how to land, especially in bad weather conditions, and then driver assisted features that we will look into real soon. Now, the level of automation in the transportation sector is dominant mainly in air and land systems. Today we'll be majoring in these two systems of transportation and their level of automation. Today we won't be discussing futuristic concepts, concepts that are not yet realistic, concepts that are not being developed. We'll be looking at concepts that are currently being developed, concepts that are realistic, concepts that has gone through a particular rate of acceptance or non-acceptance in the industry, and I'm sure you will enjoy that. Today we'll be exploring how a lot of automated robotic systems we'll be exploring a lot of automated robotic systems in the transportation sector, namely navigational aids. We'll be exploring autonomous driving systems, especially the driver assist features. We'll be exploring autonomous driving systems, again the self-driving feature, which features autonomous navigation. We'll be looking at advanced autopilot systems lastly. Actually, advanced autopilot system is also embedded in the autonomous driving system segments, so I'm sure you'll be able to understand this from here. So let's kickstart. Navigational aids now. Navigational aids are the first of the kinds of automation system that came into the transportation sector. In this picture you can see a typical GPS in the car. Most cars, most modern, relatively modern cars rather, they have a GPS system inbuilt. What the GPS does mainly, is just to show direction. I have GPS on my phone too. Every smartphone owner has a GPS, and what it does is basically the same thing. It shows your location relative to a location you want to get or you want to reach. Over here you can see the location of the right here you can see the location of the driver. You can see where he aims to get to, and one of the advantages of navigational aids is that it helps you see faster routes of getting to the places you need to get to. So navigational aids are applicable to both air and land travels. That's something you should note. Now, navigational aids in air transport includes instrument landing systems that helps pilots safely land the aircraft during low visibility flights, usually due to very bad weather. Have you asked yourself, how do airplane pilots actually land in situations whereby the weather condition is extremely poor? Let's say foggy weather conditions where you can't even see 2 meters right ahead of you. They use a system of navigation that is called instrument landing system, which automates the entire landing system. Now, navigational aids in land travels usually includes navigational maps for drivers to find their way when lost or stuck in foggy weather conditions. And like I explained earlier on, in mobile systems in vehicles, it comes in form of the GPS system that's widely used today. So right now I will let you see, and I will play a video for you that explains and adequately explains the concept of right now I will show you a video that accurately explains the principle of how instrument landing systems work in aircraft, and I'm sure that will allow you to and help you to gain cognition of what it's used for, what it's not used for, and what it's all about.
The ILS refers to an instrument landing system used in airports all around the world. With ILS, landings are managed safely in all weather conditions. During the approach and before landing, airplanes are guided by air traffic controllers using radar screens. Through radar vectoring instructions given by air traffic controllers, airplanes are guided to be lined up behind each other, intercepting the ILS signal for landing. From the control tower, air traffic controllers manage takeoffs and landings. They also organize the ground traffic. The ILS system uses a combination of two independent subsystems, one composed of antennas located on the ground and one on board the airplanes. On the ground, the localizer antenna, situated at the end of the runway, transmits a radio beam that indicates the runway center line. A second transmitter, the glide slope, is situated at the edge of the runway, and its beam indicates the correct vertical descent profile. In accordance with International Civil Aviation Organization standards, the angle of this approach slope is 3 degrees. The intersection of the approach slope with the runway center line given by these transmitters represents the ideal descent path. The receiving antennas on board the aircraft pick up and display this information on a screen in the cockpit. The landing airplane will follow a fixed trajectory with a slope angle of 3 degrees down to the runway surface. During the final phase of the flight, the air traffic controller guides the airplane towards the localizer beam. The pilot watches the ILS receiver screen, where a vertical pointer indicates the runway center line. The pilot then levels off and slows down in order to configure the aircraft for the final descent. The descent starts when a horizontal pointer indicating the descent slope crosses the pointer indicating the runway center line in the center of the screen. The landing trajectory is then fixed with a continuous descent profile down to the runway. This sequence, recorded 3 kilometers from the runway, shows the precision of the ILS system. We can see all the airplanes safely separated and following exactly the same trajectory.
So I'm sure you saw the level of precision and accuracy that this sort of system, even as primitive as it is, it still provides the same quality of the same quality of results that has always been producing. And there was once this skepticism that maybe autonomous flying systems in aircraft to actually replace conventional pilots. And yes, that could be possible. That sort of system could be possible in the near future, but there's no way to tell for now. Humans still trust their human pilots, to take them from one place to another. So personally, I see these these systems of automation not replacing human pilots in the next few years. In matter of fact, the next few decades. Except there is very, very huge and disruptive technology that facilitates that. So right now, I want us to explore another means, another automation system that has gained wide traction in the transportation sector. So let's talk about autonomous driving systems, especially the let's focus on the driver assist aspect for now. So one of the earliest systems of automobile automation is the driver assist features. Let's look at what that entails. There is a varying range of features that different automobile companies embed in their driver assistance systems. The feature of automatic driving system that has driver assist embedded is usually referred to as ADAS. That Advanced Driver Assist System or Advanced Driving Assistance System, and that simply refers to a technique by companies to try to help drivers to try to basically increase safety, yes, in the transportation industry. Let's look at Toyota's driver assistance system. Toyota represents one of the most popular car in the world today. So we'll take a look at Toyota's driver assistance system and also Tesla's driver assistance system. Now, one of the features of Toyota's driver assistance system, from now on I'll start referring to it as ADAS. One of the features of Toyota's ADAS is the pre-collision system. In other words, the car will actually alert you when you're close to colliding with any object. You understand? It's similar to the obstacle avoidance systems present in modern drones today. So if you're moving too close, if your proximity to an object is bearing relatively closer, the pre-collision system will alert you and will let you know what's happening. Secondly, we have the lane departure alert for the Toyota's ADS. The lane departure alert allows you to, it informs you when your car is drifting off a particular lane, and this is useful in case you slip off during a very long journey, and your car is veering away from the highway. It will alert you immediately that hey, this is what's happening, and obviously it would save lots of lives. Road signs assist. These features, especially this particular feature, is actually one of the most revolutionary one, simply because it combines an aspect of machine vision that is cutting edge and that is relatively new. So imagine you trying to overspeed, or let me say, imagine you driving from here to another state, and you get to the highway and your car sees that the speed limit on one of the road signs is 50 miles per hour. What your car would do, if it has road signs assist features, is it automatically slow down. Yes, it will slow itself down to 50 miles per hour. Now you can decide to override that, you can decide to switch it off and overspeed, but in such situations the car will slow itself down and automatically adjust to the road signs. If the road sign reads that there is a crossing or there is a bend ahead, it will either alert you or try to follow the bend and curve itself, and these sort of systems are actually extremely useful. You agree with me? Now there's a lane tracing assist tool that actually allows you to automatically follow your lane without need to be controlling the steering every time. Now there is full speed dynamic radar cruise control. Let me explain the lane tracing assist a little bit more. Imagine you're driving and it suddenly starts raining and it's so foggy that you can't see anywhere. Now this lane tracing assist will actually allow you to see if you're still following your lane, if you are veering off the lane. The lane tracing assist alongside the lane departure alert will allow you to get an idea of if you're going correctly, if you're going wrongly, because now you have GPS, right? But GPS itself can't tell you if you are precisely going on the correct course, because as beautiful as GPS is, the GPS still has about 10 meters error. In other words, your car could be veering off the lane or the highway by 10 meters and GPS won't allow you to know. GPS won't let you know. GPS will still give you the feel that you're following the right direction. You understand? So that unreliability is replaced and is patched by these features, lane tracing assist. So if you combine lane tracing assist with your GPS, you'll be able to follow your lane, you'll be able to maintain it at the same time following the GPS sign, and obviously that will get you to your destination quicker. Now the full speed dynamic radar cruise control is another thing. So let's say you're driving for, you're going to be driving for 200 kilometers, yes, and it's a highway, you understand. Now you want to rest for, let's say, you will get there in 15 minutes. If you're driving super fast, so let's say you get there in 25 minutes and you just want to, take a nap for about 10 minutes. You can literally put your car on cruise control, but the car will be adjusting itself. The car embedded with these other features will automatically adapt itself to the speed, will stop itself from colliding with another car or other object, will ensure that you stay on course, will read road signs to know which speed limit to adjust to, and will ensure you're still tracing the lane. You understand? And it will combine all this to be able to adapt and to be able to readily slow down or speed up depending on the signs these other features are reading. So the full speed dynamic radar cruise control is one of the cutting edge technologies again that's gaining traction in autonomous systems, especially in the automobile industry today. Let's talk about Tesla's driver assistance systems. Let's see how it differs from Toyota's ADAS system. Now Tesla has a lane centering feature in their ADAS package. Now you would ask me that how is it the same with Toyota's lane tracing assist? It's actually the same. You understand? You just gave it a different name. It's almost entirely the same. Adaptive cruise control is the same thing as this Toyota's functionality via full speed dynamic radar cruise control. Self parking. Now that's one of the outstanding features of Tesla's ADS. It means your car can literally park itself. You walk into a parking lot and the place is already filled up, but there should be 1 or 2 spaces. You simply get off. I'll show you a short video right now that will allow you to see this in action. You simply get off and just give the car the command to find a suitable parking space and park itself right there. Just like, hey, you car, get yourself sorted out, something like that. Automatic lane changes. Tesla can do this. For example, you have a car in front of you, you're driving at 70 miles per hour and there's a car in front of you, and Tesla's ADS system already already notifies you that there's a car right in front of you. The car can automatically switch lanes itself without the driver's intervention. You understand? Or if a car is over speeding and is close to colliding with another car right in front of it, your car can automatically switch lane to maybe a nearby lane that's not being occupied or that is currently safe for that moment. And this is one of the outstanding features again of Tesla's ADS. Semi-autonomous navigation, and I wrote here that this varies because there is an aspect of full-scale automation. Hope you know, driver assist or ADAS systems, it's let me say a semi-autonomous feature rather for cars. There's the full autonomous system and there's the half autonomous system. Let me put it that way. Self-driving vehicles is a typical example of the full-scale aspect of autonomous driving systems or ADS. You understand? But driver assist packages or ADS systems is an example of half autonomous system. In other words, not fully autonomous. There's still somebody that has to be in charge of the steering wheel. Despite all these features embedded in the ADS system, there still has to be somebody there monitoring the vehicle, trying to get things in order, typically driving the car himself. It's only that these features will allow the driver to rest a while, take control of the car again. That's why they call them semi-autonomous systems or semi-autonomous features. So right now, to show you a video that allow you to gain cognition of how these cars work, what they do, and how they do what they do. So I'm sure you enjoyed that. That's Tesla's ADS package in action. So right now I want to show you what self-driving aspect of ADS systems feature. Now, the advanced form of advanced driver assist systems, which is ADS packages, is self-driving cars. These are cars that drive themselves. They do not need human intervention. Actually, there are still levels of autonomous cars. There's still a level that is prescribed by some sort of government council, and I think it's level 1 to 4, and it varies based on how involved the driver will be in the course of the driving. There is a level whereby the driver does not even need to do anything. I think that's still the highest and the most advanced level, where the driver can sleep, the driver can eat, the driver can have a discussion, with his friend. You can chat, you can do anything, just about anything you want in the car, and the car will get you to your destination safely. That's the highest form of autonomy for now. Now, as described, they are simply vehicles that can combine all the features of an ADS alongside with full-scale autonomous navigation capacity. Basically, these vehicles are vehicles that have all the features of the conventional ADS we listed earlier, and they can still navigate it themselves automatically without human intervention at all. I told you the other time that ADS system still requires there to be some sort of human intervention, either minimally or wholly. You understand? But when we talk about self-driving cars, we're talking about a full-scale ADS without any need for human intervention. Now, self-driving vehicles has found application in several places, including cargo transportation, autonomous shuttle systems too. Now, one thing I want to clarify is that there are companies that have tested most features of self-driving. You understand? They've tested the self-driving feature on most cars. They have found out it works, but no company has fully deployed a self-driving car itself right now. But there are self-driving shuttle systems, there are autonomous shuttle systems that can take passengers, not just one person, not just personal cars right now, but that can take passengers from a place to another. You understand? Now, this is easier to implement because, for example, I want to go from my hostel to my college. My hostel to my college is A to B. You understand? From my college to the cafeteria is B to C. From the cafeteria to the admin building is C to D. I can simply develop an autonomous system that will master the route from A to B, from B to C, then from C to D, and we follow the lane precisely, as opposed to you developing a full-scale system that can be implemented everywhere, anywhere. In other words, the car will get to a 3D environment. It's actually the only thing it has of the environment is the map, and we'll still be able to drive it comfortably. So you agree with me that one is actually harder to implement than the other. It's easier to implement a self-driving car that follows a series of logical routes. You understand? Take me from A to B, return me from B to A. Take me from A to B, return me from B to A. Hostel to college, college to hostel, hostel to college, and it follows that route every blessed day. The car would have gathered enough data to be able to steer itself extremely accurate. Now, the same thing applies for cargo transportation. Massive cargo systems are now, being self-driving cars are now being used for massive cargo transportation and even minimal cargo transportation, because it's easier to actually, since there's a predefined lane and predefined route, not lane now, predefined route that the car would follow. Not like it changes, not like it's adaptive, not like it varies from time to time. It's a predefined route. Take me from Kano to Katsina, take me from Ilorin to Abuja. You understand? It's easier to develop a full-scale map, or to be able to develop the artificial intelligence systems in self-driving vehicles to be able to adapt to let me say predefined and pre-known events, you understand, and precedences, you get. And that's actually easier. If you look at this picture here, you see that this is actually how the typical Tesla's ADAS system, this is how the dashboard looks like. So over here the picture actually shows how Tesla's dashboard looks like. So if you're in a Tesla and you're driving, this is typically what you see. You see the speed in real time, you see where you're going, you see it's actually beautiful. Because one of the advantages of you implementing all these systems is you get to have a much more advanced car. You understand? Now most of this system is easier to implement. The self-driving car itself is easier to implement in electric vehicles. Why? Technically, it's actually easier to manipulate the controls of an electric vehicle as opposed to the other one, other counterpart, which is vehicles that uses the conventional propulsion system. One is easier than the other, you understand, and that's where the advantage is. Right now I want you to see a video of Tesla of the cargo transportation system that is implementing self-driving features. It's a relatively new company, very new startup rather, and it's called Plus AI. So I'll be showing you a video from Plus AI that's showcasing how the cargo transportation autonomous system works. Also, I'll be showing you a typical video of the shuttle system, also the autonomous shuttle system that's being used in some colleges in the United States today.
to Ollie. This is an autonomous self-driving shuttle that's going to start operating on campus from today. And we're incredibly excited because I think we're probably one of the few campuses in the country that actually are going to be running an autonomous shuttle for students in engineering departments. So that's where I'm from. It's an incredible opportunity to learn about how these shuttles operate. Are they safe? And the perception of the users towards accepting these as the technology of the future. And so that's what excites us a lot. And obviously serving our campus community as well in terms of their mobility needs, that's the other part of it. Right, so this is the control panel and also a screen which shows the route that Ollie takes. And basically Ollie has sensors outside, including a camera and something called a LiDAR, which is a laser that's constantly monitoring the environment around it, and that's displayed here on the screen. And there will be an attendant while Ollie is operating on our campus, and the attendant will have the ability to take control in case there's any unforeseen situations, circumstances. The attendant will have full control over the vehicle and be able to make an emergency stop. And so that's what these controls are all about.
And now it's up to us and the students and everybody around campus to just interact and just see how it works and see if everybody likes it, refine the service, refine the product.
So that's that about that. You can see the implementations and the beauty of these vehicles. Well, you'll be asking that, so what is the advantage of all these vehicles, all these innovations in the transportation sector as opposed to the traditional way of doing things? Well, firstly, to a certain degree, these sort of systems are still reliable than human counterparts. You understand? It's easier to tell a robot or a robotic car to simply drive people from A to B, B to A continuously for a day. You don't have to pay any driver. You don't have to, do anything. You just give the robot the instruction and it will automatically carry it out. You understand? As opposed to a human worker that will have to get paid, will get tired, you understand, or is subjected to a lot of errors. There are a series of accidents that are occurring in the world today based on human errors, you understand. And conversely, these autonomous features, these advances in the transportation sector promises a better future that will lead to, ultimately the goal's goal of maintaining the maximum or the maximally attainable level of safety on the road today. And yes, robots are promising that future, a future whereby we could have very few, less than 5% or less than 1% accidents per year, or sometimes a futuristic concept whereby you can even have zero accidents, because most cars are now autonomous. They know what to do. They can interact with each other using IoT. They can switch lanes. They can take it from a place to the other. They can park automatically. So you can have ideally a future whereby there will be zero road accidents. Yes, it's possible. That ideal kind of future whereby the ozone layer will stop depleting, because now most companies are now switching to EVs, and this is an achievable goal. And yes, a lot of companies are moving to the front line to achieve those goals right now. There's Tesla on the front line. There's General Motors now, trying to diversify into the electric vehicle sector, and eventually the ADAS systems too. We have Toyota. We have Mercedes itself is diversifying too. So in the future, I see a rise in the massive increase in the number of electric vehicles we have on the road, which will automatically usher in the era of self-driving cars at the extremely advanced levels. And for now, we still have these ADAS systems already implemented. If you buy a typical Tesla, you can request for the ADAS package to be installed in your car or to come along with your car. Yes, these systems are already available. The lane assist, lane centering, the cruise control, all those ADS systems are really available in most Tesla vehicles right now, and in most Toyota vehicles and every other automobile company that is offering these ADS packages. So today's seminar was a relatively short one. I want to appreciate everyone for joining me once again. Tomorrow will be the last installment of this seminar. I'll be talking about where I'll be giving you a sneak peek into that. We will be, discussing the advancement of robots in the area of research and development. We'll be looking into space travel. We'll be looking at most systems you're expecting us to discuss, most futuristic concepts that you expected us to discuss, but we didn't. And tomorrow's video might span for an hour because I'll be showing you a series of videos. I'll be showing you Sophia. I'll be showing you how advanced she is, what she's used for, what her potentials in the future might be. I'll be showing you most futuristic concepts, especially self-balancing scooters, just even smarter city designs. You're watching lots of videos and you'll be hearing a lot from me also tomorrow in that regard. So thank you very much for joining off or going along with me on this journey so far. My name is Salakolu Adolapo, and I wish you a very, very comfortable and very nice day. Thank you.